Alright, welcome back to the channel, and in this video I want to, well actually in the next few videos, 4 or 5, I'd like to spend some time going over some of the basics of reading and writing files, so using the system.io or input-output. And so we're gonna cover reading and writing data to or from CSVs, text files, JSON files, and JavaScript files. We're going to talk about some of the benefits and challenges of each, maybe some different use cases and that sort of thing. And we're also going to compare using string addition versus string concatenation. We'll do that in the JavaScript section, or a couple of videos that we talk about where we use JavaScript. We're going to write to JavaScript files, and in that example we're just going to run some tests to see which is more efficient, and then we'll also talk about kind of why one is more efficient than the other. And then most of the code in the project uses string interpolation, but there will also be a couple of examples of using string.format. And so if you're familiar with the ESAPI, then you'll know that, or you may have experienced where you can't use string interpolation in certain instances, like if you're using like a single file plugin. So sometimes you're limited to only being able to use string.format, and so we'll kind of show an example of how we might do the same thing each way. And so, like I said, this will be split up into several videos. So part 1, which will be this video, will focus on CSVs. We'll have an example of reading Beam template data, and we'll talk about its usefulness and limitations for reading and writing data. Part 2 will be on JSON, or JSON, which stands for JavaScript Object Notation, which is a data-only file format. So like no comments and that sort of thing. The example of that will be reading both patient, like some dummy patient data, and Beam template data. We'll do the same test. We'll actually read more beams with the JSON example than we do with the CSV, and then we'll be able to see like what the speed is compared to each. So in the project we'll be using stopwatches or timers for each thing, so we can kind of test things. The third video will be either one full video, or will be split up into 2 parts. One focusing on the JavaScript aspect, and then the second potentially focused on how you might use that JavaScript file, how you might load that into an HTML document. So one of the benefits of using JavaScript files is that you can include JavaScript objects, but you can also load those into HTML, and you can, in those files, in the JavaScript file, you can also include other JavaScript code, or you can use other JavaScript files in conjunction with whatever you've written from whatever data that you've saved to the file. You could then display or view or manipulate in an HTML document using different JavaScript libraries and that sort of thing. So that's maybe you might find that interesting or useful, or whatever. All right, and then like I said before, in this example we're going to be writing data, and we're going to test how long. We're going to compare using string addition versus string concatenation. So we're going to be building a string over a user determined number of iterations, and so as you can imagine, the more iterations, the string will get larger and larger, and so we'll be able to see how that affects efficiency and memory and that sort of thing. And then in the final video, we'll just we'll talk about some logging and some examples of how you might use text files for logging different things. We'll show an example of how you might want to log like a script's use, whether or not it was used successfully. Like for example, in this project, we're just going to log whether or not there was an exception that occurred, and if there is an exception, we're going to include some of that information, that sort of thing. So anyway, so with that, we will go ahead and get started. I'm going to pause the video here for a second, and start back once I have the project open. Alright, so I've opened up the project, and as you can see there's kind of a lot going on, but we've got different models for each thing, and then we have some different data, some example file data and that sort of thing. So just quickly, so why might you want to read or write data? If you're if you're limiting your scripting to ESAPI or whatever. So you might want to collect some data, or maybe you want to load some data from files. Like maybe you're wanting to try to automate some either plan template imports, or maybe auto planning, or something like that. With ESAPI, there's different methods that you can use to create different types of beams, and so instead of hard coding things, oftentimes it's nice to collect that data from an external document like a CSV or a JSON file, because those files are external, so they can be edited much easier than would need to be done if you were hard coding everything. So when you hard code, like say plan objectives or beams or anything like that, then in order to make any changes to those, you actually have to make the changes in your code, and then rebuild it, reapprove it if it's writing to the database in any way, and then put it back in your scripts folder. Also, you'd probably want to test it just to make sure that everything is still working appropriately and that sort of thing. Whereas if you just have a file, then you just change the file and it loads, the thing. Which also comes with its own challenges, because if it's in a location where it can be deleted or changed easily, then you could open yourself to other challenges as well. So assuming that you want to move ahead with either data collection or loading data from a file, like reading data, then you might want to use some of these things, some of these different file types. All right, so the file types, like I said before, we're going to talk about CSVs, JSON files, JavaScript, and text files. And then these are some of the methods that are available through the using system.io. So there's a file. So if we uncomment these, then this file is from system.io.file, and we can read all bytes, we can read all lines, and read all text. With read all lines and read all text, you have the opportunity to pass in which type of encoding, if you know the exact type of encoding that the file used when it was made, then you can pass that in as well. Reading all bytes, that's not an option, but with all three you have, with the encoding is optional for these two, and for all three you really just need the path to the file. Read all bytes returns a byte array, read all lines returns an array of strings, and read all text just returns one string. So like maybe you have something secure that you want to keep in one file, right? And you want to get that from that file, you could just read all text. Or if you know exactly how to parse or split that string, once you have it, then you could do that as well. So anyway, so that's an example of that. In this project, we have some different variables. We have we're going to use the ConsoleX plugin or NuGet package that Rex Carden published, and then we have some timers. We have a way to get the project directory using this code right here. It returns the bin and debug, since that's where this builds to. Don't want that, so this lives in the main project folder. So we just want to be able to access these directories and these files right here. So we get the project dir, then we create a log path, and then we create the various different paths that we need, which is just the project dir plus some of this information. And then we just have a general stopwatch or timer that we'll use to start and stop for each task. We have one complete timer that we'll use to time the entire length of the program, and then an individual timer that we'll use to start and stop for each individual task, so that we can compare things. All right, so moving on to the topic at hand, we have CSV files. So CSV stands for comma separated value. So think, overly simplified spreadsheet. You can't resize column. I mean, you can resize the column, but it doesn't persist. Nothing persists except for the data. So if you make a bunch of change the background, whatever, when you go to save it, if you save it as that CSV again, then none of that will persist. So the nice thing is that you can open it in a text file. You can open it in a spreadsheet. So like this is a screenshot of this particular file saved in a spreadsheet. So we have columns for beam type, ID, comment, machine ID, energy, dose rate, primary fluence model, technique. If you're familiar with the ESAPI, then you'll recognize these as being the items that you might need or that you would need to create your machine parameters. Also leaf positions. Then you have the information that you would need to create to define your jaw positions. You have your collimator angle, gantry start. That's the gantry angle. Gantry stop is here. So if you had like a setup field or a static field, then this would just be empty. So basically it's all of the information that you would need to create any type of beam, and then you just leave things empty as you need, right? And then you have your couch angle and then your ISO positions so that you can create your V vector for your ISO center. Your jaw positions are V-rect, so you would just create that using there. And then I use this column right here. This is just an example. This is an example solution that I came up with for this project. But you could define like a beam type in your spreadsheet to tell you what type of beam method that you would need to use in order to create your beam. And then it would also tell you what information you're supposed to have, right? So we'll go over the logic for this because it's just some examples of how you might want to validate your data and that sort of thing. It won't be, a perfect solution. It's going to be missing some stuff, but anyway. And then, so that's how you can view it in a spreadsheet, but you can also view it in a text file, like so. So if we make this bigger, then you can see that everything's just separated. All these the data is actually just separated by a comma, which makes sense because it's named comma separated value, right? Whereas like if you have like tab, maybe you have a file where a spreadsheet and you saved it as where tabs were your delimiter. Then when you open it in a text document, you would see a tab in between each column of data. So these are very useful in reading or writing data because they can be visualized using a spreadsheet, right? Which is easy. You can order, you can group, you can filter, things like that. Like you can sort, that sort of thing using Excel spreadsheet. It just won't persist once you go to save. So the biggest challenge that will come with CSV data is that, or CSV files, is that it's basically two-dimensional, right? You have a row and you have a column. Well, with a lot of our data, it's nested. Like an object can have a property that is another object, and that property that's an object will have other properties that maybe you want to collect as well. So depending on how many levels of data that you're trying to save, you might wind up having to write duplicated data in every single row. Like for example, if you want to save like some structure data, or like say a beam data, right? Let's say you want to collect some information on different plans and their beams, right? Well, you would need to, because you have your patient, right? That patient has courses, which is a courses property, which is a list of courses essentially, or course objects. That course object has a bunch of different properties, one of which is the plan setups, right? And then the plan setup has the structure set, which has the structures, the list of structures, and then each structure. So imagine where in every single row, instead of only being able to include the structure data, you also have to have columns for patient MRN, patient ID, course ID, plan ID, structure set ID, all these things, and then you have to duplicate that in every single row of your data. So that could be, depending on, again, how many levels of data that you want to be able to identify later on in your analysis or whatever, then you may find that you're just being too redundant in your data, right? So that's a challenge that you can find in CSV files. The other thing with CSV files is obviously everything that's separated. Every time you see a column, it inserts a new, every time that you see a comma, it inserts a new column, right? And it puts the data, whatever it sees after the column, after the comma, into the next column. And so there's a caveat to that where you can, if you wrap whatever data, because imagine you have a comment or you have a notes property, right? And in that note, it could contain a comma. Well, if it does, then you just need to think ahead and you just wrap your, whatever that value is, with double quotes. And once, if it's wrapped in a double quote, then it will ignore the comma, right? It's kind of like an escape character. If it sees that it's in part of a string, which, the double quotes will tell it that it's a string, so it will just preserve that entire piece of information as one piece of data, or in one column, as opposed to splitting it off into different columns or whatever. So you just have to be careful, and you have to think ahead and try to predict when you might expect to see commas and that sort of thing. All right, so if you wanted to save, let's say you wanted to save a bunch of plan data, right? Well, you might have different plans for the same patient. The same patient may also have different courses. So how would you save all of that data? It would be really difficult to save all of that in a single file with a CSV, right? Otherwise, you would have so many different levels of repeated or redundant data, because you would need extra columns for. Now, that said, you could, if you really think through, then you could put all of your beam data or whatever into a single column, as long as you know how to later on separate that data back out. So like if you wrapped your data into a double quoted string, right, then you could separate each thing by a comma, and then at the end of each beam you could use like a semicolon, right? So that then when you're analyzing the data later, and if you're using Python or something to parse your CSV, then you could split by the semicolon, and then that would give you each beam object, and then you could split further by the comma, and then that would give you could split each beam object that you get after splitting by the semicolon, you could then split by a comma to give you like each of the individual properties of the beam, right? So like if you knew the first thing that you gave it was the ID, the second was, whatever they are, right? Then if you would have to just know, you'd have to understand what the structure is there. So that's like, you could do that if you wanted to do it in a single file, or instead you might have something like this, where you have maybe you have a folder for each patient. And then once you get into the patient's folder, then you have a folder for each course. And then once you get into the courses folder, then you have a folder for each plan. And then maybe here, now we're at our smallest level. And so now we have a file for beam data. We have a file for plan data. And then we have a file for structure data. And then you could have different files for like objectives, or whatever. Like process objectives, that sort of thing. So like, say for example, in our beam data, if we open this up, we've just got like plan ID, beam type, energy, whatever data that you wanted to collect. And then same thing for plan data. Maybe you have some generic plan data that you want to collect. But the thing to think about is that in this, you would also want to include like the patient ID, the course ID, the plan ID. So that way you have some identifiers other than just the plan ID, right? So think of this patient ID and course ID as foreign keys that would help you group data later on. If you let's say you combined a bunch of these files into a single file, then you would know which how to group the data later on. So give me 1 second. I need to pause the video. All right, so that's just an example of a potential solution that you could have for that. Okay. All right, so let's see. CSV files, though, they do lend especially well to saving or reading specific object data. Like if you only want to read in beam data, right? That's one layer of data. Now, with the exception of in our example, we have when you create a beam, you need a machine parameters object, right? Well, so instead of having a machine parameters column, we have columns for each of the individual things that you need to make up the machine parameters, right? And then same thing to create the jaw positions. We don't have a jaw position column. We have an x1, x2, y1, y2. That's the information that we need in order to create the jaw position object or whatever. So that's an example there. So if we go, instead of creating a specific MLC arc beam, so remember we have this beam type MLC arc beam. When we're reading the data, we don't necessarily want to have to do all of that logic up front. Maybe we just want to read in the beam, and then later on we'll process it, and then we'll use this to tell us what type of beam we need to create later on in our code or whatever. So we're just going to create a list of generic beams, and then from there, because maybe you want to read in, in your template, maybe you have arcs, but you also have setup fields, right? So maybe you have a template where you want to read in both types of beams. Well, then you would need a list of that specific type of beam that you want to create, but then also you would need a list of setup fields, right? And then imagine all the different scenarios that you might have. Well, in this case, what we're going to do, we just have a generic beam that holds, it's just a dummy model that has all of the basic information that you would need to create any type of beam. So you have your ID, this beam type, which is just, again, this is just a dummy. It's not an actual, it's not an ESAPI type. It's just a dummy type to help for this solution, to help me figure out what type of beam I want to create. And then we have a mock-up of the machine parameters, because obviously in ESAPI it's not called machine parameters model, it's called machine parameters, at least I believe. So this is just a dummy. This is all dummy stuff, where it's kind of fake, recreated models to emulate what we would do in ESAPI. And that's because I'm just reading it from a file, and then I would take this information later on and then create the beam. And the reason that I've named everything similarly is so that when I'm creating a beam, I don't have to guess what, I don't have to go looking for what I need to make the machine parameters. I just named it machine parameters. So it'll be machine parameters equals machine parameters, right? That sort of thing. Or I'll feed in each of these parts into the method that creates the machine parameters. So anyway, so that's just an example. So that's what we're doing here. Like I said, it's just one solution. So we're going to create a list of generic beams from CSV. So we just have this method here in the CSV model called load beams, and all we do is we create a list, an empty list, and then for each line in file.readAllLines. So if you want to read a CSV file, this is one way that you can do it. You can just use file.readAllLines and then pass in the path. In this case, there's not a need to pass in any sort of encoding. And then so for each line, what we're going to do, we know that a comma separates each value, right? So then what we're going to do is we're going to separate the data by, we're going to split the line, we're going to split the information with a comma. And so that's going to give us an array of strings, and then data, the index position 0 of this data will be the beam type, right? Because the first column is beam type, and then so on. So we have our beam type, our gantry direction, valid dose rates. This is just, I'll go over this example really quickly because it's an example of how you might want to validate the information. So like for the dose rates, you could very easily imagine where you accidentally type 60 instead of 600. Or so this is just a list of what the valid dose rates are. So this is just an example. They could be anything, whatever your machine or whatever you like to use, you could use that. So it's just a list there, and then we're going to test. So when we're trying to parse, create a number from a string, there's different ones. So we have int, we have doubles, things like that. Float, I think float even has a parse. I can't remember. So you could. So int 32.try parse, what this is going to do, this is going to try to parse it, and it's going to return a Boolean of whether or not whatever we pass into it, if it's a valid integer, then it will return true. If it's not valid, then it will return false. So, and then if it's true and it's valid, then it will return, it will pass out this dose rate, this variable that we're creating in line here. We're saying out, we're going to pass out an integer called dose rate, and that would be the same thing or similar thing if we did int dose rate 1 and then dose rate 1, but we wouldn't need this, right? So that would be the same thing there. So but we'll just do it this way. So all right, so then we're going to test if valid. So if the dose rate that it returns, because like I said, you could just have a typo. Maybe you just typed 6 or 60 or 6,000 or whatever. And even though that's a valid integer, that doesn't necessarily mean it's a valid dose rate, right? So if this list contains whatever value is parsed out, as long as that's false, as long as that's true, then we'll just use the dose rate. Or as long as, or if the dose rate is a valid integer as false, if this value is returned as false, then we will use this value. So really what you could do is you could test this first, because we would know if this is false, then this definitely won't be true, right? So you could reorder these if you wanted to. But basically we're just going to say if it's not in this list, or if it's not a valid integer, then we're going to give it a default value. Okay, and then the same thing, maybe you want to do something similar for the jaw position, and then we create the jaw position. So we're going to get out these doubles if they're valid. As long as they're valid, then we'll use them. If they're not valid, then we'll give preset values, and we do them I'm just doing it individually, because let's say that one of the x's is invalid, but the y's are valid. We could still use the y's. We don't have to use the default for the y just because one of the x's is wrong. Okay, and you could even do that for each one, where like if x, you could, instead of doing or and setting both, you could just do each one, right? So and another maybe cleaner solution would be x1 equals, let's see, and I'll just do this for 1. So if this is true, then we could pass in x1. If it's not true, then 10, right? And then you could do that for each one. So I think that would probably work. That might be a cleaner solution instead of testing whether like setting the default for both, even if only one is not valid. I don't know. It doesn't really matter. So that could be an example of how you can come up with your own solution on how you validate your data. Maybe you don't even want to validate it. Maybe you just know that it's going to be correct, and there you go. Here's an example of using double dot parse. Here we're not actually validating it, so we're just assuming that it's going to be correct. And we're creating a new view vector for the isocenter. And then we're going to just add to the list of generic beams, we're just going to add a new beam with whatever this information is. And then we also have like the collimator angle, gantry angle. Like I said, you would probably want to validate these, but in this example, I'm not going to go through all that. And then we're going to return the list of beams. So that's that method. And so if we just hit start, let's see, we're at 30 minutes. That's not terrible. So if we just hit start in our program, I'll drag this over, and we can see that 2 beams were collected from CSV in 4 milliseconds and done. Press any key to exit. So we loaded 2 beams in 4 milliseconds. We can see that's really fast, right? So that's really straightforward. It's a lot of explanation and talk for like 2 seconds of actually showing the program. But I wanted to go into some of the background for when or why you might want to use a CSV, and then also like some of the challenges that you may encounter as well. And then if you want to write a CSV, you can do the same thing. Just know you just separate each value as a comma in your string, and then you add like new lines as you go or whatever, and then you write to that file, and then voila, you have a CSV. So just really quickly, I know that I mentioned it in the to-do, so this is an example of string interpolation. If we were going to do this with dot format, I think I have an example here. I thought I had an example somewhere. Oh well. Oh well, I won't waste your time looking for it. But if we just copied this, we would get rid of this. As soon as we get rid of this $, you'll notice that the object, so this beams from csv.count, this is now part of the actual string. So if we printed this, it would actually tell us. We would actually see this. So let's just test it. Whoops. Drag this over, make it bigger. So we can see like now this is just part of the string, right? So it's not getting the information all because we removed that. So what we would need to do here is we would need to do string.format, add brackets, and you can use the uppercase string, but you don't have to. That was just a typo. And so what we're going to do here is we're just going to cut out this, and we're going to replace it with a 0. So it's going to be a 0-based index, and that's just a placeholder. So then we're going to separate our string. So the first parameter is the string, and then we're going to pass in each additional parameter that goes along with its respective placeholder. So I'll cut that out, replace it with 1. And then I'll paste it here, and so now if we should get this twice in a row, right? And sure enough, we do. So we can see that that's exactly the same, right? All right, so I would just, whoops, let me just comment this out. All right, so with that, I'll move on to the next video, but we'll stop here. Thanks for joining, and we'll see you in the next one.